Hello all, welcome to C programming tutorial. Today we will see how to check whether a given number is strong or not. So to understand whether a number is strong or not, we must understand the definition of the strong number. A number is called strong. A number is called strong if the sum of factorial of its digit is equal to the number itself. So we need to understand what is meaning of factorial. So I hope everyone knows the factorial. So if I asked you 4 factorial, factorial is represented like this. Its meaning is that we have to do 4 into 3 into 2 into 1. So multiplication from that number to 1 up to 1. So that is nothing but the factorial. Alright. So what the definition says, a number will be called as a strong number if the sum of factorial of its digit. So assuming that if I have 3-digit number as 1 to 1, so what definition says, sum of factorial of its digit. That means factorial of digit. So what digit we have here? 1 to 1. So 1 factorial, then 2 factorial, and then again 1 factorial. So what is 1 factorial? 1. That is 1 into 1, right? So 1, then next is 2 factorial, that is 2 into 1, and next is 1, that is 1. Now here 2 into 1 is 1, so we got 2. So we got here factorial of the digit of 1 to 1, that is 121, is equal to how much is the sum? So sum is equal to here 1 plus 2 plus 1, that is equal to 4. Now here let's call this 121 as number. So whether number and sum of the factorial of the digit of that number are same. So whether num is equal to sum, yes or no? It's no, right? So we can say that 121 is not a strong number, not a strong number. Now the next case next, let's say my number is 145. So in case of 145, the digits are 1, then 4, then 5. So tell me the 1 factorial. So 1 factorial is equal to, let me put here the symbol, 1 factorial is equal to 1. 4 factorial. So how much is the 4 factorial? 4 into 3 into 2 into 1. So I have already written here. So I will just copy this. Control C, Control V. Okay, how much is the answer? 4 into 3? 12. 12 to the 24. So there is 24, right? And now the 5 factorial. So 5 factorial is 4 factorial into 5. So I am writing here 5 into 4 into 3 into 2 into 1. So how much it is? 24 5s are 120, right? So 120. Now let's perform the addition of 1 factorial, 4 factorial and 5 factorial. So 1 factorial is 1, 4 factorial is 24, and 5 factorial is 120. So how much the answer is? 145. So let me make it as sum is equal to 145. Let me put here num is equal to the declared number as 145. So here in this case what we observe that num is equal to sum. The number given, original number given, is equal to sum of the factorial of the digit. They are same. So as they are same, so answer is yes, it is true, right? So let me put here true, T-R-U-E, true. It means that the number is strong. Number is strong. Is this clear to everyone? Right? So how to find whether a number is strong or not? Sorry, strong or not? So number is strong, right? Okay. Now what task we need to do here? We need to do 2 tasks. Task number 1 is to separate the digits, and second task is to obtain factorial of each digit. Then next task is to perform the sum of the factorial of each digit, and then finally comparing the sum of the factorial of each digit with the original number. So if they are same, our answer will be number is strong. If answer is not same, our answer will be number is not strong. Is this clear? Okay. So already we have seen the logic of separating the digits. Logic of separating the digits. So we will begin with int. Okay, we will begin with int num as declaration of the number. So let me take 145 as that number. Okay, then now in this case we are going to calculate factorial. So we need one variable as fact. Okay, as we have to find the individual digits in the n digit number, 3 digit number, 4 digit number, any digit number, right? We have to find individual digits. So that is what we will get by using remainder. I hope you remember the Armstrong code. In that we have separated the digits of 3 digit number, right? So same logic we are going to use here. So we need remainder, we need let's say the number to accept the value. Okay, and again we are going to use some iterator variable. So why we are going to use iterator variable? So let me declare at that time only. ठीक है, उसी वक्त हम declare करेंगे. Fine. So number, fact and remainder. So the first task that we are going to do is to find remainder of the division to get the digits. So what we are going to do? Very simple. What we are going to do? See, we are going to do while what? The number is greater than 0. See, in the logic, when we have separated the digits, we have performed n divided by 10 and n mod 10. Eventually, our n is becoming 0. That means the number of digits are over, right? So we have to stop there. So that's why the logic in while will be n greater than 0. Now, as our number, let me put here number. As our number is going to become 0, that means from 145 it is going to become 0. We can't compare sum with the number. So we have to create a temporary variable. So what we will do, again we will declare int temp, and that is equal to num. Int temp, that is equal to num. Okay. So now after writing the while loop, assuming that the number is, we ask user to please enter the number and everything. Okay. So we will take what? We will calculate we will first separate the number, right? So to separate the number, what we do this, what? Remainder is equal to the number that we are using mod 10. So here we are going to get one number as a remainder. Okay. So after this, what we are going to do? Whatever that remainder we have got, that for that remainder we have to perform what? For example, if the value of remainder is 4, for example, I'm just telling the example. If the value of remainder r is equal to rem is equal to 4, it means what should happen? It means it should be like 4 into, or let's say 1 into 2 into 3 into 4. That means we have to start multiplying 1, then 2, then 3 and then 4, right? So what we are going to do, we are going to use a variable as fact, factorial variable as fact. Okay, and that factorial has to be multiplied with 1, 2, 3, 4. 4 is what? N number. So remainder, right? So in this case, what we are going to do, we are going to use one more while loop. Because we have to start multiplying from 1 to n, but we don't know what is value of n, right? In case of for loop, we know the total number of iterations, but in case of while, when we don't know the total number of iterations, we go for while loop. So here we will go for one more while loop. In that while loop, we will put what? An iterator value I is less than equal to num, remainder, rem, that is remainder. So till that value is less than equal to rem, what we have to do? See here, what we are going to do? 1 into 2 into 3 into 4. So 4 is what? N, right? So here in this case, what we are going to do? Fact is equal to fact multiplied by I. So here what is going to happen? First we need to declare fact as equal to 1. We need to declare fact as equal to 1. So when we will declare fact is equal to 1, see what is going to happen to the first iteration. Here, see this code. What is going to happen to the first iteration? So let me write here. Let me put this in, let's say, bracket. Okay, opening bracket, and here it will be a closing bracket for this. Okay. So what is going to happen now for the first iteration? Now assuming that my number is 145. So 145 here as first iteration, 145 is greater than 0. So condition is what? True. 145 is greater than 0, right? Condition is true. It will come here. It will initialize the value of fact by 1. Then remainder is equal to num mod 10. So let me remove this now and let's see what is the value of remainder. So now see 145 is my number, mod 10. Mod 10. So remainder. So what will be the remainder of this division? 5. So 5 is the remainder, and that is nothing but my first number, whose factorial I have to calculate. So now I will start with calculating the factorial of this number. So what I did, while I equal to, now see here, the most important thing, I am using I equal to, I is less than equal to remainder. But whether I have initialized the value of I? No. And we have to start multiplying from 1 to n. So we will now initialize I with 1. Right, and then we will take that I to 4, to n, right, to 5, to n. So here what we will do, after fact we will declare I is equal to 1. So that two things we will do, fact equal to 1 and I equal to 1. And now here what will happen to the first iteration? Now we got the value of remainder as 5. So here the first iteration is, in first iteration, whether 1 is less than equal to 5, that is what is the condition, and answer is true. 1 is less than 5, right? It will come here and it will perform what? Fact equal to fact into I. What is value of fact? 1. What is value of I? 1. Fact and I both are 1, 1. So we are going to get here answer as 1 at the first iteration, right? And now after multiplying with 1, we have to multiply it with 2. So value of I should be increased by 1 now. So we will do here I plus plus. Now iteration number 2. What will happen? What will happen in this while loop itself? What will happen? We will go to the we will go to iteration number 2. So in iteration number 2, let me write here, iteration number 2, the value of I is now here. The value of I will be increased to now 2 because it was previously 1. So now iteration number 2, the value of I is now 2. So 2 is less than equal to 5. Condition is what? True. As this condition is true, it will enter in the while loop. Now what is current value of fact? 1. So it will now fact is equal to, so what is value of fact? Fact is equal to, see, fact is 1, value of I is 2. So 1 into 2. So answer will be 2 after iteration number 2. So let me put here iteration number 2. Okay. Now it will come down here, and after iteration number 2, the value of I will become now 3. Again we will go to this while loop here, for this while loop, and in iteration number 3, see, 3 is less than equal to 5. Condition is what? True. So it will enter here, and now current value of fact is 2. So it will be 2 into value of I, that is 3. So how much it is? 6. Current value is 6. Now it will come down and it will make or increase the value of I by 1. So it is going to become now 4. So we will go to now iteration number 4. In iteration number 4, see, what is current value of I? It is 4. So whether 4 is less than equal to 5? Yes, condition is true. It will come inside, and now the current value of fact is how much? 6. Now it will be 6 into 4. 6 into I value is 4. So 6 into 4 is 24. That is the value of fact. And now here the value of I will be increased by 1, that is 5. So at iteration number 5, the value of I is what? 5 less than equal to 5. 5 is not less than 5, but 5 is equal to 5. Out of these two conditions, one condition is true, that is equal to. So again our while loop is true. It will come to this and it will do 24 into 5. So how much is 24 into 5? 120. 5 factorial is 120. Alright. So here we will come down. I value will be increased by 1. It is going to become 6. Now at iteration number 6, listen carefully. At iteration number 6, it will be 6 less than equal to 5. So whether 6 is less than 5? No. Whether it is greater than 5? Whether it is equal to 5? No. So condition is false here. Condition becomes false here. So when the condition becomes false, this block of code will not be executed and we will get first value of fact. First value of fact, that is factorial of first digit, that is 5. Now this value of factorial we have to add somewhere. So where we have to add this value? In the sum. In sum we want sum of factorial of number 1, factorial of number 2, factorial of number 3 and so on. So what we will do, we will have one variable here and that variable is sum. So after end of the while loop we are going to put sum is equal to sum plus fact. Sum is equal to sum plus fact. Now whether we have declared some variable? No. So we need to come here and we have to declare sum. As we are performing sum plus, so there is a possibility of garbage value. So we need to reinitialize or initialize sum with 0. Once the sum is calculated, that means what is going to happen now? We are going to get sum. So after the sum, that is we have found sum with digit 5. Now we have to go to 4. That means we have to reduce 145 to 14. And for reduce purpose, what we have done? We have used a logic as num is equal to num divided by 10. I hope you are remembering the logic of division and modulus. This is going to reduce your number by 1. So here in this case, the value of num is 145. When we will divide it by 10, we will get integer division as 14. And now when our while loop will start again, here again our while loop will start for iteration number 2. Here for iteration number 2 it will start and now it will check what 14 is greater than 0. So yes, condition is again true. So same logic will be executed throughout the 4. We will conclude our outer while loop. Is this clear to everyone? Inner loop, how inner loop executes and how outer loop executes? Right? Okay, fine. Now, once this is done, we have to check whether sum and temp. In temp, we have temporarily stored the value of num, our number, that is 145. So we need to check at the end. What we need to check? If what sum is equal to temp. So if they are same, then we are going to print. What we are going to print? The number is strong. And if it is not like this, then we will go in else part and we will print. What we will print? Number is not strong. That's the end of the program.